In the last video, you learned how to write the location of all the electrons in an atom using electron configuration and orbital notation. In this video, you will focus on the valence electrons and learn to draw Lewis dot diagrams, which are important for the next unit when you learn about chemical bonds. Valence electrons are in the outermost energy level, or shell. Note that the sodium atom has its one valence electron on the third energy level. They are most likely to be the electrons involved in bonding, which you will learn more about in the next unit. Knowing how many valence electrons are in an atom can be helpful in predicting oxidation numbers, which is the charge an atom has in a compound. Noble gases are considered to be inert, so their outer shell is full. In other words, they have a complete octet, or 8 electrons. Here are the steps for drawing Lewis dot structures. Write the symbol in the middle. Determine the number of valence electrons and place them around the symbol. And remember Hund's rule, place single electrons before you double up. Remember that the valence electrons are in the s and p orbitals of an energy level. In group 1, all these elements have one electron in the s orbital, so we would like to draw their Lewis dot structures with 1 dot, which represents the one valence electron. In group 2, all these elements have 2 electrons in the s orbital, so we would draw their Lewis dot structures with 2 dots. In group 13, all these elements have 2 electrons in the s orbital and 1 electron in the p orbital, for a total of 3, so we would draw their Lewis dot structures with 3 dots. In group 14, all these elements have 2 electrons in the s orbital and 2 electrons in the p orbital, for a total of 4, so we would draw their Lewis dot structures with 4 dots. In group 15, all these elements have 2 electrons in the s orbital and 3 electrons in the p orbitals, for a total of 5, so we would draw their Lewis dot structures with 5 dots. In group 16, all these elements have 2 electrons in the s orbital and 4 electrons in the p orbitals, for a total of 6, so we would draw their Lewis dot structures with 6 dots. In group 17, all these elements have 2 electrons in the s orbital and 5 electrons in the p orbitals, for a total of 7, so we would draw their Lewis dot structures with 7 dots. In group 18, almost all these elements have 2 electrons in the s orbital and 6 electrons in the p orbitals, for a total of 8, so we would draw their Lewis dot structures with 8 dots. There is one exception to this rule, and that is helium, which only has 2 electrons in the s sublevel, and therefore only has 2 dots. In problem 11, you are to draw the Lewis dot structures for the following elements. Potassium is in group 1, so has 1 valence electron. Aluminum is in group 13, so has 3 valence electrons. Phosphorus is in group 15, so has 5 valence electrons. Carbon is in group 14, so has 4 valence electrons. Chlorine is in group 17, so has 7 valence electrons. Krypton is in group 18, so has 8 valence electrons. Pause the video and answer the questions. When you are finished, continue for the answers. Here are the answers to the questions. In this unit, you have learned the types of electromagnetic radiation, the relationships between energy, frequency, and wavelength, and how to calculate these values. You have learned how to describe the placement of electrons using electron configurations and orbital notation, and you have learned how to draw Lewis dot structures based on the number of valence electrons an atom has. In the next unit, you will learn how atoms exchange or share electrons in order to form bonds with each other. Good luck on the exam, and thanks for watching.